So we kind of ended in a weird spot last video, so I'm just going to pick up where we ended. So just a quick review, because I know some people are still struggling with logs. Logs was last chapter, but if you're working on some things, I want to do a quick review here. So the 3 is multiplied by the x squared, so you break it apart, so it's 3, and x, the power of 2, becomes the number in front. The 2 minus x is being divided by x cubed, so we have 2 minus x the cubed becomes the number in front. The square root of 2 is like 2 to the 1/2, so the 1/2 natural log of 2. The 3 is then to the 1/2, so it'd be 3/2 natural log of x, all being divided by 5, so it's minus natural log of 5. And then the opposite, condensing. So this time we have a minus, so it's 8 divided by x to the power of 2, so 8 divided by x to the power of 2. The 1/2 makes this x minus 1/2 a square root, and then the plus log 7, so the 7 is being multiplied by that right there. So just a quick review. Hopefully that's all familiar with you. Now let's move on to our essential question. So now we're going to look at what is the graph of the tangent function. It's going to be really unique. You're going to see graphs like you've never seen before. So here is the graph. We're going to graph this. So grab your notes. We're going to start the notes here. And we are going to graph or grab a calculator and just figure these values. On your notes, you only have the values that I'm marking. So only mark these ones here. And grab a calculator and fill them out. And you get this. So the tangent of negative pi over 2 is undefined. And remember, you should have your calculator in radian mode because we're doing it in terms of radians because it has that pi in there. So in your notes, you should have these values. So you should have undefined, -1, 0, 1, undefined, -1, 0, 1, and undefined. Notice a pattern here. It's kind of unique how that goes. And now we're going to look at graphing them. The graph of tangent x has vertical asymptotes at x values where tangent x is undefined. So the first thing to graph the tangent, I'm going to graph those asymptotes. Well, we notice from our table that we have an asymptote at negative pi over 2. So there's going to be a vertical asymptote right here. And there's also going to be one right here. So remember, asymptotes are where the graph is undefined. And then we see that at negative pi over 4th, the value is -1. At 0, it is 0. And at 3/4, or pi over 4th, it is +1. So that's right here. And this graph actually comes up like this, over, and then it goes on. And then that is what the graph continues to do. It, I'm going to put the points in right here. So it comes up, crosses, and then continues up. And then each cycle, that's what it's going to look like. So the question is, for the graph of y equals tangent of x, identify the asymptotes the x-intercepts and the intervals for which the function is increasing or decreasing over negative pi halves up to 3 pi over 2. Is the tangent function even, odd, or neither? Well, when we graph it, it looks like this. So we notice there are asymptotes every pi distance across. So the function never crosses at that point right there. The y-intercepts is 0, and there are several x-intercepts. There's an x-intercept at negative pi, an x-intercept at 0, an x-intercept at pi, and 2 pi, and so on, and that repeats up. Is the function increasing? Well, it's increasing in between the intervals. So in between this interval here, it's increasing, and then this period is increasing. Is the tangent function even, odd, or neither? Well, we could say this is an odd function, but we have to limit the domain. So if we are just looking at pieces in between, so for example, if we're just looking between here and here, it is an odd function because it has all the characteristics of an odd function. It begins at negative infinity, ends at positive infinity, and it has this odd symmetry to it. So, just some core characteristics of tangent, and then we'll look at cotangent too. The domain is all real numbers except odd multiples of pi over 2. That's where the vertical asymptotes are. The cotangent of x is all real numbers except multiples of pi. We'll look at the graph of the cotangent in just a second. The period of each graph is pi. The range is all real numbers, so the functions do not have a max or a min value because it's everything. And the x-intercepts occur at all these places right here, 0, plus or minus pi, plus or minus 2 pi, and cotangent is just halfway in between that. The period in vertical asymptotes can be found. The period is found by taking pi and dividing it by b. Remember, b is the number in front of the x. Vertical asymptotes are pi over 2b, and the vertical asymptotes for cotangent are just pi over b. So in your notes, let's do these examples. Identify the period and determine where 3 asymptotes occur for each function. So the period would be pi divided by b, which is at 2, so it's pi over 2, that's the period. And then the asymptotes would also be then multiples of odd multiples of pi over 2 times b, which is 4. So every pi over 4 period there would be an asymptote. The next part, the tangent of pi times theta. So the period would be pi over pi, or just 1. So the period would be 1. And then the asymptotes would be pi over, write this one down, 2 pi, which would then be 1/2. So the asymptotes would be every half unit. Tangent of 4 pi. So this time the period would be pi divided by 4. So that's where each period, every pi fourths, there would be a new cycle, a new period. And then the asymptotes would be pi over 8. You kind of seeing a pattern here, right? So the last one, this one, the period would be pi divided by b, which is 1/3, which is multiplied by a 3. So the period would be 3 pi, so it'd be really stretched out over 3 pi. And then the asymptotes would be pi over 2 times b, which is 2/3, which would then be 3/2 pi. Okay, cool thing is you can always use your graphing calculator to graph them. So graph one period of g of x equals 2 tangent of 3 of x. So take a second and graph it either on your calculator or on Desmos, and it would look like this. So this shows that it is the amplitude has been stretched. So instead of just going up to here, is now going up to here. The asymptote is closer together. So there's an asymptote right here and here. And oh, the period, sorry, I kind of skipped over that. The period would be pi divided by b, which is 3. So every pi thirds, there's a new cycle. And the asymptotes could be found by taking pi and dividing it by 2 times b, which is 6. So the asymptotes are pi 6 apart. Okay, let's look at cotangent. So cotangent is the inverse of the tangent. And so I'm just going to graph this on Desmos real quick.